Hello, this is Cody Newman, and today I'm going to be giving an overview of the iSyncBrain EEG Summary Report. This video is for clinicians hoping to use this report in their practice, or for individuals who have received an iSync scan and want to know how to interpret their results. So to start with some background, what is EEG? EEG stands for electroencephalography, and you may have seen some squiggly lines like this if you've gotten an EEG scan before. Each one of these lines corresponds with a different electrode placed on the scalp that is actually able to read the neuronal activity, those neurons firing in your brain on the surface, and then magnify that so we can actually analyze those results. Then we use some complicated mathematical procedures to convert these squiggly lines into different ways of representing that data. A lot of this is based on the speed or frequency of the waves that we can see. We're going to talk a little bit about what these common brainwave frequencies are, starting with delta in the 1 to 4 hertz range. These are slow waves. Generally, you'll see them in sleep or unconsciousness. There's not a lot of them in a waking state EEG. Next, we have theta waves. These can be associated with creativity, insight, and deep states, as well as unconsciousness. They also can be a sign of drowsiness, daydreaming, kind of a lack of activity in that part of the brain. Next, we have alpha. This has to do with alertness and peacefulness. This is kind of like the conductor keeping your brain on track at a specific rhythm. Then we have beta. This is a thinking wave. You can think of when you see this wave, that part of your brain is turned on and active. Then with high beta, this is kind of a more intense version of beta. This can start to get into the dangerous region, more closely related with things like anxiety or hyperalertness. And lastly, we have gamma. This has to do with a lot of complex problem solving. You can kind of think of this as the actual content of the brain, but you don't really see it too much as well in a waking state EEG. For the report that we're looking at today, we're just going to be focused on these theta and beta waves. And for our purposes, you can think of theta as kind of daydreaming, turned off brain waves, and beta as turned on active waves. And what we do in this report is we take the ratio of how many theta waves to beta waves for all these different regions in your brain, and then compare your theta-beta ratio to our database of almost 1,300 healthy brains. These are EEG brain scans of people who have been vetted by doctors to have no mental or physical health issues, so it gives us a nice baseline to compare to. Now we're going to talk a little bit about statistics. This is a Gaussian distribution. This is just a way that things are distributed statistically. And for an example, we're going to talk about height. Let's say someone is 4 feet tall. They might be in the bottom 10 percentile for height. They're in the smallest part of that graph. There's not a lot of people that height, and they're on the lower side, compared to someone who's maybe 5'10", right at the 50th percentile for height. Most people are going to be in this center segment of this curve because most people are average or close to average. And then on the opposite side, we might have the 90th percentile, people who are 6'2". These people are also outside the norm, but on the higher end. Another way of thinking about this is with standard deviations, where most people are within one standard deviation, the big segment in the middle of that curve. And as you go out to these higher standard deviations, you're farther outside the norm, and that becomes more statistically significant compared to if someone is pretty close to average. So with that background out of the way, let's actually take a look at the iSyncBrain EEG Summary Report, starting with our brain age analysis. So this first image is highlighting places that are 1 standard deviation underactive or 1 standard deviation overactive. And again, we're getting this idea of underactivity or overactivity based on that ratio of slow waves to fast waves. So if you have some orange in the scan, that means you have more slow or less fast compared to that normative population. So what does it mean? If you have a lot of underactivity in your brain, that can be a sign of attentional issues like ADHD. It can also have to do with different sorts of learning disabilities, if that part of your brain has to do with some learning tasks. We also see a lot of slow activity in head injuries because during a head injury like a TBI, a lot of neurons die, so there's less firing going on there, less beta activity, and you might see a big orange splotch. On the other side, we have that blue overactivity. This can be associated with things like anxiety, hyper-alertness, hypervigilance, also just brain turned on. Different medications can have an effect on your overactivity as well as your underactivity in the brain. Your brain also might have some overactivity if it's compensating for an area that is lower. We like to use the waterbed analogy, where if your brain is slow in one region, it's going to have more power in another region to kind of make up for it. And that's what we're highlighting on this first image. Next, we're going to start breaking down more specifically with percentiles all the different parts of your brain, starting with a lobe by lobe approach. So these numbers on the right for the left and right hemisphere for each lobe are those percentiles that we talked about earlier, where 50% means you're exactly at that average, exactly near that normative baseline. And as you get lower, you have more underactivity, and as you get higher, more overactivity. Where it becomes statistically significant is when you're more than one standard deviation away, which is when you're below 16% or above 84%. And that's what we'll highlight as significant. So now let's actually talk about all of these different lobes, starting with our frontal lobe. This is the part of your brain used for high-level cognitive function. You can think of this as the thinking part of your brain. This is the part that's making decisions, planning for actions. It's basically your thinking brain. This one, when it has underactivity, is a sign of ADHD in some cases, and overactivity can be a sign of anxiety in some cases. Next, we have the temporal lobe. This is the part of your brain right behind your ears. This has to do with auditory processing and memory encoding. So issues with underactivity here could relate to an auditory processing disorder, also just general auditory comprehension, understanding what people are saying, understanding the sounds you are hearing and processing them correctly. It can also be a sign of some sort of deeper memory issue because the memory centers of your brain are kind of behind this area. And then having overactivity here, again, could also have to do with some auditory processing issues like tinnitus. Then we have our parietal lobe. This is right above that temporal lobe. This has to do with sensory processing and integration as well as learning. So underactivity here can be related to different learning disabilities. And then on the other side, overactivity can be a sign of things such as autism spectrum disorder, disorders, issues where you have trouble with sensory signals. That part of your brain might not be processing them correctly. Lastly, we have our occipital lobe. This is in charge of visual perception. Everything you see gets sent to the back of your brain, and that's where it gets processed. During these scans for this report, your eyes were closed, so you shouldn't really be using a lot of energy in the occipital lobe. So having a higher than average score here might have to do with being hyper-vigilant of your surroundings. Even though your eyes are closed, your brain is still processing what's going on around you or thinking of visual stimuli. On the other side, low scores here could have issues with visual perception. That has to do with not just object perception, but also understanding what objects are or imagining objects in your head, as well as we see a lot of low activity in TBIs or concussions here, because this is a pretty common place for a brain injury to occur. And the last section on this first page starts with our standardized brain function score. This is just an average of your entire brain, again with 50 being completely average, higher more overactive, lower more underactive. Then we have this little scatter plot below, where on the vertical axis we have those fast beta waves, and on the horizontal axis we have those slow theta waves. And then each one of these little dots is one of your lobes, right or left hemisphere, plotted against that blob, which is the standard distribution of healthy people. So you generally want your dots to be around that blob, but what we're trying to avoid is being in that bottom right quadrant where we have a lot of slow and not a lot of fast. That can be some severe underactivity. And on the other side, being on the top left quadrant, a lot of beta waves, not a lot of those slow theta waves. We can have an overactive brain, some sort of hyper alertness, or just general overactivity. So that gives you kind of a summary of your whole brain, and then the rest of the report is going to start breaking down the actual lobes into regions of interest, or ROIs. We're not going to go over all of these, but we'll go over the first one, the frontal pole, as an example. First, on the left, you can see the name of the region, as well as highlighted in blue is where that region is. The blue here isn't showing overactivity, it's just saying that's where the frontal pole is in your brain. Then we give some general key functions for that part of the brain. So the frontal pole is used for planning and organizing for action, evaluating outcomes, and transitioning attention. And then in functional decline, these are the observed symptoms that we see. So as you might imagine, difficulties in planning or a tendency to repeat similar mistakes. And then on the right, we have those percentiles again, where 50% means normal, lower than that means underactive, higher than that means overactive, and below 16 and above 84 is where it becomes statistically significant. So an important thing to note when you're going through this part of your brain is the brain is a very complex network. So just because one of these scores is low doesn't necessarily mean that you're going to have troubles with that region. And like I mentioned earlier, the brain is very compensatory. So if part of your brain has a low score, probably the areas around it are kind of picking up the slack. We can also imagine a lot of these low scores due to head injuries, drowsiness, or different medication type effects. Now, if you see a low score in a region that does relate to you, it's something that you struggle with, this can give you an idea of why that might be. And if it's something you don't struggle with, it can give you an idea of what to look out for in the future. Because as that compensatory mechanism, as the rest of your brain kind of gets overworked, it'll stop picking up the slack, and then your brain's going to have to figure it out. So this gives you an idea of what to look for, and if you start to see those functional declines, now you can know why and hopefully treat it sooner rather than later. So with all that said, that was the EEG Summary Report by iMedisync. Thank you for watching.